Welcome to this tutorial that overviews ANOVAs and MANOVAs. This is Dr. Amanda Rackinson-Zapke, and over the next few minutes we're going to talk about the different types of ANOVAs and the different types of MANOVAs. We're going to talk a little bit about a one-way ANOVA, a two-way factorial ANOVA, a repeated measures ANOVA, a MANOVA, and a few additional analyses. We're going to look at when a researcher might use each of these and what a researcher needs to conduct each of these analyses. So let's go ahead and start talking about a one-way ANOVA. A one-way ANOVA is used to compare the means on a quantitative outcome variable across two or more groups. So a researcher needs to have two variables. First of all, they need a categorical independent variable with two or more distinct groups. And some people say three or more distinct groups, because if you only have two groups, then you can remember you can use an independent t-test. So at least one categorical independent variable and one continuous or quantitative dependent variable. Let's say, for example, a researcher randomly assigns students to different types of courses. Let's say there's an online course, a residential course, and a blended course. And the researcher wants to know if these students' sense of community within the course will differ based upon their course assignment. The researcher may ask, is there a statistically significant difference in the sense of community among students based on the type of online course they take, either online, residential, or blended? Here, since we have one quantitative dependent variable, sense of community, and one independent variable, type of course, that has three groups or three levels or three distinct categories, a one-way ANOVA is the most appropriate choice. Now, once you do the F-test on a one-way ANOVA, and it's significant, most likely you'll then need to follow up doing post hoc tests, but we get into this in another tutorial. Here it's important that you understand when to use a one-way ANOVA. And as a reminder, you use a one-way ANOVA when you want to compare the means of a quantitative outcome variable across two or more groups. A two-way ANOVA is similar to a one-way ANOVA in that the researcher wants to compare the means on a quantitative outcome variable across groups. Now, when I say groups, I don't mean just one group in this case. The researcher's actually interested in looking at two or more group membership variables, oftentimes called factors. So for a two-way ANOVA, a researcher needs two categorical independent variables and one continuous dependent variable. Remember when we talked about the one-way ANOVA, the educational researcher simply asks, is there a statistically significant difference in sense of community among students based on their type of course? But maybe this researcher finds some literature that suggests that there may be a difference in community based on gender. So he or she is interested in looking at not only the type of course that individuals are enrolled in, but also how gender interacts with the type of course. So the researcher asks, is there a statistically significant difference in sense of community among students based on the type of course, while gender remains constant, and based on gender? Here, what the two-way ANOVA allows the researcher to do is to simultaneously test for two main effects and one interaction effect. So the researcher can see if if there's a difference in community across gender, if there's a difference in community across the type of course a student is enrolled in, and if there's an interaction between these two variables. For example, does community differ based on the type of course for males and for females. So what he or she may find is that males do better in one type of course, whereas females do better in another type of course. So here it's important for you to remember that a two-way ANOVA is used whenever you as the researcher have one dependent variable and are interested in two independent variables, and their support or if something suggests, the literature suggests that there may be an interaction between those independent variables. Now, I want to make a real quick note here. Sometimes in statistical texts and research texts, you will not see a two-way ANOVA. Rather, you'll see a chapter or a discussion about a factorial ANOVA. A two-way ANOVA is a type of factorial ANOVA, and in fact a factorial ANOVA is often used in a research situation where two or more group membership variables are of interest. So they can be a three-way ANOVA or a four-way ANOVA, depending on the number of independent variables that the researcher is interested in. With the one-way and two-way, between groups ANOVA, we've assumed that we've had independent samples. That is, each group consists of a different set of participants, and each of those participants is a member of one and only one group. So there's no systematic pairing or matching between the participants. The assumption is, under these conditions, that the participants' behavior or answers on a test or an instrument do not interact. They don't influence one another. However, sometimes as a researcher, you or the researchers interested in matched, paired, or yoked scores that are correlated with each other. And in this case, oftentimes a repeated measures ANOVA is the best choice. A repeated measures ANOVA can be used whenever the researcher is interested in matched pairs. For example, let's say the researcher is interested in husbands and wives, or the researcher is interested in looking at how a group of individuals change over time. And that's the example we're going to look at with a one-way repeated measures ANOVA. Let's say that there's a researcher and he or she's interested in looking at not if sense of community differs between types of courses, but rather if sense of community differs over 3 periods in which students are enrolled in a program. Let's say the researcher is interested in the student sense of community at the beginning of the program, the middle of the program, and at the end of a program in which they're enrolled. And let's say specifically it's an online program. Here you can see that the researcher needs to have two variables, one independent variable that's categorical, and that's usually time whenever we're looking at the same group over a period of time. Here in this example, we're looking at 3 different time periods, but with the repeated measures ANOVA, you can have 4 time periods or 5 time periods. So you need an independent categorical variable and a dependent continuous or quantitative variable. In this case, that would be the score on the sense of community assessment. So this technique, or the one-way repeated measures ANOVA, will tell the researcher if there's a significant difference somewhere among the 3 sets of scores. So for example, the researcher may find out that there's a statistically significant difference in student sense of community at the beginning of the program compared to the end of the program. So whenever you're using any type of data that's matched, paired, yoked together, and there's a correlation among the observation because you're looking at the same group of participants at different points of time, a one-way repeated measures ANOVA is the most appropriate analysis. To this point, we have looked at the one-way ANOVA, the two-way ANOVA or factorial ANOVA, and the one-way repeated measures ANOVA. In all the example research scenarios, what you'll note is that the researcher was always interested in one dependent variable. Let's say, however, that the researcher wants to look at more than one dependent variable. Maybe the variable that we've been looking at, sense of community, the instrument that the researcher is using actually has 3 subscales or 3 distinct constructs, and the researcher wants to look at each of these as different dependent variables. let's say the researcher wants to ask, is there a statistically significant difference in online students' sense of social presence, cognitive presence, and teaching presence, the three distinct constructs within the construct of community, based on the type of course that they're taking, either online or residential. Now, since the researcher has one independent variable and two or more continuous dependent variables, he or she needs to consider a one-way ANOVA. Now, you may be asking at this point, well, if you have three dependent variables, why not just do multiple one-way ANOVAs? Well, if you do multiple one-way ANOVAs with dependent variables that are correlated or related, you run the risk of increasing type 1 error. So another analysis called a MANOVA is often used. Now, a MANOVA, I just told you the variables you need, but there's an important point here. A MANOVA is used when you have one categorical independent variable and two or more continuous, related, or correlated dependent variables. If the dependent variables are not related or correlated, you can do multiple t-tests or multiple one-way ANOVAs. But if they are correlated to decrease the risk of type 1 error, a MANOVA should be run. And this is because with a MANOVA, it actually looks at the linear combination of the dependent variables together before each is considered separately. So again, a MANOVA helps the researcher, helps you compare two or more groups in terms of their means on several correlated dependent variables. Now, we just talked about a MANOVA and when to use it. It's important to note here that a MANOVA can also be extended to a two-way or factorial design. So you can actually have more than one independent variable. You can have, just like with the ANOVA, you can have a one-way ANOVA, two-way ANOVA, or factorial ANOVA. The same is true with a MANOVA. It's also important to note here that you can also have a repeated measures ANOVA. But a MANOVA is used by a researcher when the researcher is interested in more than one dependent variable, and he or she knows that the dependent variables are related or correlated. Now, before we end this tutorial, we're going to briefly take a look at two additional analyses. The two additional analyses we are going to look at are the mixed within between groups ANOVA and the ANCOVA and MANCOVA. Let's start with talking briefly about the mixed within between groups ANOVA. Let's say that the researcher wants to actually combine a one-way ANOVA and a repeated measures ANOVA. That is, let's say the researcher is interested in following groups of students across their programs. And remember, when we talked about the different programs, we talked about a residential program, an online program, and a blended program. Let's say that the researcher wants to look at not only the difference between student sense of community in those three programs, but across a period of time within those three programs. So the researcher is interested in looking if there is a main effect in the independent variable and also an interaction effect between the two variables. So in this case, the researcher may ask which type of program is more effective in increasing participants' community scores across 3 periods of time. Prior to the program, or at the beginning of the program, during or in the middle of the program, and then after the program. So sometimes a researcher may want to mix the repeated measures and the one-way ANOVA or two-way ANOVA we talked about, and this is called a mixed within between group ANOVA. Another analysis that is often used in educational research, because a true experimental design in which a researcher can randomly assign participants to two groups and assume group equivalence is impossible, they oftentimes need to give a pretest. And if a pretest is given in a quasi-experimental design, it has to be controlled for, and it's often controlled for using statistical analysis or statistical control. So let's say that in our scenario that we've been talking about, this researcher cannot randomly assign participants to an online group, a blended group, or a residential group. And so he or she needs to pre-test. So students, let's say, choose their different groups. So that what the researcher would want to do is pre-test the students before they enter the course. So he or she gives a community pre-test, and then after the students participate in the course, the students are given a post-test. When the researcher wants then to statistically control for the pretest or the confounding variable. So he or she may then use an ANOVA. Now, you can add a covariate such as a pretest, or it doesn't necessarily even have to be a pretest. It could be another confounding variable such as gender or something else. But anyway, if you ever want to, or a researcher ever wants to statistically control for the possible effect of a confounding variable, he or she adds a covariate to the analysis. The example I just gave, the researcher would use a one-way ANOVA because the researcher was simply looking at the difference between three groups with the covariate of the pretest on one dependent variable. But it's also possible to have a covariate for a MANOVA. So looking at the pretest scores of the dependent variables and then controlling for those pretest scores and then looking at the differences between groups on those post-test scores. So anytime that there's a pretest or confounding variable, a covariate needs added, and a MANOVA or ANOVA may be the most appropriate analyses. So in summary, we have talked about a one-way ANOVA. Remember, that's when a researcher wants to look at the differences among two or more groups on one dependent variable. We've looked at the two-way or factorial ANOVA. That's when the researcher wants to look at two or more independent variables and the effect of those independent variables on one dependent variable. We looked at the repeated measures ANOVA. Remember, the researcher uses this when the researcher wants to look at matched pairs or look at the same group of participants over a period of time, for example, measuring them before, during, and after a treatment or an intervention or participation in a course. We then looked at the MANOVA, and the MANOVA differs from the first three analyses or procedures we looked at in that the MANOVA allows the researcher to look at more than one dependent variable, and remember that the researcher uses the MANOVA when the dependent variables are correlated or related. We then looked at two additional analyses, the mixed within between groups ANOVA. That's when the researcher really wants to combine the one-way ANOVA and the repeated measures ANOVA. And then we briefly talked about the ANOVA when the researcher wants to add in a covariate or statistically control for a confounding variable such as individuals' pretest scores. So this completes our overview of ANOVAs and MANOVAs.